All right, I'll go ahead and get started, and then let people in as they appear. But hello, thank you all for being here. Happy GIS Day. Just so you know, we are recording. Gotta let you know that at the beginning. My name's Jillian Urbach. I'm the Tech Training Coordinator at the EDC. If you don't know the EDC already, we're the Economic Development Council for San Juan County, and we focus on local business assistance and retention, workforce development, and just overall building economic resilience in the islands. Before we begin, I want to acknowledge that the EDC resides and works on the ancestral lands of the Coast Salish people who have called this place home and have been stewards of the land and water since time immemorial. I think we might have a bit of a mix tonight of folks who maybe have never heard of GIS before and are wondering what it is, as well as some folks who maybe have more experience with it or even use it in your own work. It's starting to kind of gain more attention, I think, but there's still a lot of people who it might not be on their radar at all. And we're putting on this event because we're planning on offering an Intro to GIS course in early 2023. There's been demand for GIS skills from the county and town of Friday Harbor, as well as Opalco and some other local companies. So we're hoping to get some people trained up in those skills. And we're putting some feelers out there for who might be interested in taking the course, as well as some more experienced GIS users who might be interested in mentoring the students or being a resource for people. So for those not familiar, GIS stands for Geographic Information Systems, and it's a system used to create, analyze, manage, and map all sorts of spatial data. A good way to think of it is that it connects the what to the where in order to start understanding the why and how by analyzing patterns and relationships between data. It can be used in a super wide range of fields from conservation and forestry to city planning and public health. It played a large role in tracking community and global spread in the beginning of the COVID-19 pandemic. And really almost any industry can find a use for GIS. I'm going to play a quick video from Esri, which is one of the leaders in GIS technology. They're the creators of all the ArcGIS products, including story maps, which you will all be receiving a coupon for a year-long premium subscription. And I'll be sending that to the email that you use to register for this event. So you will get that tomorrow. And they're the ones who put on GIS Day every year. So they're part of why we're here. So here's a brief video from Esri that touches on some of the global problems that GIS can help solve and how it can lead us towards achieving a more interconnected and sustainable future. Once I share my screen, please give me a little thumbs up if you can hear the video, because I just want to make sure that it's working properly. I will go ahead and turn you over to our guest speaker, John Ashoff. I'll let him introduce himself, but I'm so grateful that John could join us today to tell you a little bit about how he uses GIS. And then afterwards, we'll have a little bit of time for questions. And at that point, if any of you also use GIS in your work, I invite you to share what you're doing with it as well. But here's John.
Hi there, everybody. I recognize a few faces. I think Carmen from Whale Museum. Hi, Carmen. And we have Jill's face up there. We don't have Jill, we just have Jill's face. What I'm going to talk to you a little bit about is my personal experiences with using GIS. And let me give you a little bit of background. I've been around quite a while. When I first started doing software development, there was no such thing as GIS. And in fact, when I was taking my first programming classes, software development classes in college, we would code them on, we go to a key punch, and each line of code was on a card, and we would put the cards in a deck, and we would take it to the computer lab, and they would take our program and run it overnight. So that's when I started software development. I worked at IBM for my full career, mostly in database systems, storage management systems, and performance analysis. And I retired in 2005. I moved to the islands in 2007, and I had an interest in marine conservation. I did sound watch with the Whale Museum when it eventually was on the Whale Museum board for a while. I was on the Marine Resource Committee for a while, and I was interested in GIS for a number of reasons. I just thought it was very cool software. It allowed allowed me to do some analysis on the kind of problems that I was interested in. I also like it from the aspect of it uses different parts of my brain. I use it for it
I know this
requires
is
a little bit of
annoying, sorry.
so a little bit of analytic skill.
Are these good?
Hello. A little bit artistic side, creating maps and putting maps together uses a little bit of your artistic side of my brain and a little bit of storytelling. And I'll talk a little bit at the end about something called story maps, which really sort of folds into that. Probably about 2010 or 2011, I bumped into a fellow by the name of Dr. Gary Green. Gary he's a marine geologist. He lives on Orcas Island half the year and in Santa Cruz the other half of the year. And he had been up here sponsored pretty much by Kathy and Ron McDowell, who were the initial instigators of the CDOC Society, and they were very interested in seafloor mapping. And Gary's a geologist, and I'll talk a little bit about how he used seafloor mapping and then how I got involved in that process. Okay, so I'm going to try and share my screen here to a little PowerPoint if I can find it. Okay, so not so long ago, we used to read these paper maps, right? And we no longer know how to read these things. And this guy is really saying he could really use a geographic information system. And I'm gonna. Okay. All right. What is a geographic information system? It's basically computer software that uses many sources of spatial information. And it's to help you visualize, for example, visualizing in maps, analyze data, and then model. By model, I mean do some problem analysis, some explanation, and basically to use it as a prediction tool. You use GIS systems every day. A simple example is, Google, your Google Maps, where it analyzes traffic patterns and tells you the fastest way to get from point A to point B. Vessel Watch keeps track of, using AIS systems, keeps track of where the ferries are so that you can figure out how late your ferry is going to be. So let me talk a little bit about the seafloor mapping work that Gary had done. Starting in about 2010, they were interested in mapping the seafloor around the San Juan Islands. So Gary partnered with the Moss Landing Marine Lab and with the Geologic Survey Canada to conduct surveys of the seafloor and using a technique called multi-beam echo sounders. And what that technology does is gives the ability to send sound to the seafloor and measure the time that it takes to come back as a metric for how deep the water is. Also measures how intense the reflection is, which gives them a way of understanding how hard, a soft sediment would take longer to reflect or be less intense, and reflecting off rock would be more intense. And so that gives two pieces of information. It gives metrics of the depth of the seafloor and what the sediment types might be. It's a little bit like mowing the lawn. It took probably about 10 years working with the Canadians to do a fairly comprehensive survey of the seafloor around the San Juan archipelago. It gives very high resolution measurements. Typically, they're measuring somewhere between 1 to 2 meters horizontal resolution, so essentially giving depth measurements. every one or 2 meters. In shallower waters, it's actually it's a high resolution. So that information is basically used to analyze the characteristics of the seafloor. Now, one very simple application of that, and this is actually produced by the GIS system, is to create an image of the seafloor. And what it is basically doing is creating what are called hillshades. So this is a simulation of how what the seafloor would look like with being shaded by the sun. And you can, for example, color code different color codes for deeper water. So here we have San Juan Island, and then off the west coast of the island, the deeper channels. So one of the things that can be used is to create the imagery. In this particular case, the imagery of the islands has been created from what's called light detection and radar system, LIDAR. And this type of data is available from Department of Natural Resources. And so I use this to create this mosaic from all these various different surveys. Most of the surveys were created from Gary's surveys of the seafloor, but we also enhanced that. NOAA also uses multi-beam echo sounder, and so what was required here was to create a mosaic putting these together. So what's the usefulness to this? This is an image. This is Susha. This is Orcas Island down here, and this is Susha Island up here. So this is just an example. And what Gary did with his team from Canada and Moss Landing Marine Lab is to do an analysis of how the seafloor is composed. So, for example, these red areas that you can kind of see in high relief are sedimentary bedrock. So what you're seeing here is actually layers of bedrock that have been sort of flipped on edge and curved around. And why is it flipped on edge and curved around? It's because there's a fault that runs right through here that basically Gary had identified. It's called the Skipjack Island Fault. So what this creates is what is called a benthic habitat map. And what that means, benthic refers to essentially the organisms around the seafloor. And this gives a clue to biologists and researchers in terms of what they might find in terms of organisms. One of the classifications of the seafloor is something called dynamic bed forms, and I'll talk a little bit about where that's significant. So what you get is kind of a color-coded map of seafloor composition. So that was a piece of the work. So I'll just give a couple examples of a couple of studies that were done using this information. NOAA and Department of Fish and Wildlife were very interested in understanding habitat for rockfish, and specifically yellow-eye rockfish. Yellow-eye rockfish are on the local population of yellow-eye rockfish is considered endangered, and they had been overfished. And one of the tasks here is to understand where these rockfish are, understand what are good habitats for them, where they would find them. So that was one project involved that uses this information. The other project that I'll mention is Pacific sand lance. We're familiar with sand lance in nearshore environments, spawning beaches, for example. However, sand lance also exists in subtidal areas. And so these maps have been used in the research project to understand these Pacific sand lance. Why do we care about sand lance? They are a major forage fish for birds and for salmon. And the whales depend on the salmon, and so it's important to understand those habitats. Okay, so rockfish, where can we find them? How do we find them? How abundant are they, and how large is their potential habitat? Those were some of the nature of the research projects involved. So we use these maps in conjunction with the Washington Department of Fish and Wildlife. They go through the process of using remote operating vehicles to examine the seafloor. And you can kind of see a video of what they see when they go through this. And so they take the ROV and they're basically doing surveys to see what kind of organisms they see, what kind of fish they see. And so the way here, so what we did working with them, they were interested in understanding whether or not they could build some kind of predictive model for good habitat for rockfish, and also to use it as a tool to help them go find the rockfish. So this is Susha Island here, and what we did with them was they had probably about 20 years worth of survey data and so what we did was we took their survey information, and the little white lines here are the transects of where they ran the ROV. These little white dots are where they did some drop camera surveys, and the little green dots here are various locations where they observed various rockfish species. So we use this information to help guide. They use this information and these maps to help guide where they should run the ROV, and so that they can do some kind of analysis of where are we going to find them, where are we not going to find them. Well, rockfish, there are not a lot of surprises in here. Rockfish like rocks. They like rocks because it gives them crevices to hide in. And so we basically worked with them to sort of identify where the places are that they should be looking. We did this initially in the Salish Sea, and then did some expanded work down in the South Sound doing some analysis. So that's one application of GIS. So let's talk a little bit about Pacific sand lance. Same kind of questions. Where can we find them? How do we find them? How abundant are they? And how large is their potential habitat? Now, I mentioned dynamic bed forms. What are dynamic bed forms? Dynamic bed forms are, one way to think of them is kind of, the simple explanation is kind of like sand dunes at the seafloor. So this is Friday Harbor be up here, Brown Island is here. Well, out in the middle of San Juan Channel here, between San Juan Island and Lopez Island, is something called a sand wave field. These were, we identified potential habitat through this, the analysis of where are we seeing these kind of bed forms. So this is a close-up. This is a close-up picture of that sand wave field. And this is a place where I think it was first Washington Department of Fish and Wildlife sort of found this, but Friday Harbor Labs has done a lot of study of this area to identify the kind of grain composition, what the various characteristics are that would be good habitat for these Pacific sand lance. So what they have done is, this is a picture, this is Gary here, and they go down and they pull up the sediment, and then they go through and they look in the sediment to find the sand lance. That's a little bit of the process. And you can see here, these are some of the mapped locations of where they have found Pacific sand lance in the sand wave field. One of the researchers, Matt Baker at Friday Harbor Labs, they did some analysis of this to say, okay, given what we have found for these sand lance, how many might be here? And their modeling results have estimated that perhaps up to 70 million Pacific sand lance use this as habitat, as basically as an overwintering site. There was another piece of that research. CDOC worked with an outfit that has OceanGate, that has a submersible, because they wanted to these sand wave fields that are about 65 meters deep. So, you know, it's too deep for diving, but the submersible, they use this as a project to go investigate this sand wave field. So here's a map of the sand wave. We used our software to help track where they were traversing, so that they could use this data to understand better. And well, are you getting any sound out of this one? I don't know. Anyway, this is a video of Gary and Matt basically researching this sand wave field. Oh, whoops. Well, I'm going to change my share now. Okay, so I talked a little bit. These are some of the projects I worked on. I mentioned that GIS gives a good way to communicate information and tell a story. And Esri provides something called story maps. And so I worked on a number of these projects to convert this information into a story map format. And it's primarily a good way of communicating, telling a story, using it as an outreach mechanism. So the material I showed you here, just the snippet of material on these projects, they're in these story maps. So this particular one is the Pacific Sandlands. And with these story maps, gives you a way to intermix graphics, interactive maps. Sometimes it takes a little while for this to draw. So for example, here is a picture of the sand wave field, and the interactive maps allow you to kind of zoom around, look at the imagery. This is one of 7 story maps that were put together. This one is called these are called collections of story maps. And so in this collection, I provided a little bit of background on the Salish Sea, a little bit about the seafloor, how the seafloor maps were developed. We have a little tutorial on the geology of the Salish Sea that talks about the plate tectonics and the glaciation. Another one on the habitat maps. We recently did a project to look at the potential effects of shipping of diluted bitumen oil through the Salish Sea. It's a sinking oil, and one of the concerns was what would happen to the sinking oil if it reached the seafloor? What kind of habitats would it affect? Would it be swept through by currents? Would it sort of stick and adhere to some of the rocky areas? And so we went through and created a research paper and the story map to communicate the results of that project. If you're interested in any of this, let me go back and I'm going to do one new share. Let's see if I can find it. Okay. I have a pretty simple website. It's called www.tombollomappinglab.org. It's just a little under construction website that I did for the projects I'm working on with Gary. And at the very end of this, there is a little link here to learn more. It says learn more in this story map collection. And so click on that link and it will take you to this collection of story maps. And I'm going to go back to my keynote. And as Jillian mentioned, there's a lot of uses for GIS, and mine was just one of them. I've enjoyed working on this, and that's my story.
Awesome. Thank you so much for sharing, John.
Sure.
It's really interesting to see what you guys have been working on, and I'll include that link to the Tombolo Mapping Labs website in the email that I sent to everybody tomorrow, if you
Okay,
guys want to check that out further.
sure. So I don't know if anybody has any questions.
If not, that's okay.
Okay,
Yeah, thank you all again for being here. And yeah, look out for that follow-up email tomorrow with your story map coupon and just some more information. I'll link to the video that I failed to show you as well. But yeah, thank you. Happy GIS Day.
I do
Oh
have
yeah,
a question.
Carmen.
So if there is going to be a course, like an introductory course, how will we find out about it?
It'll be posted. Like we'll put a press release in all the papers. It'll be in the EDC's newsletter, which I can link to that in the email tomorrow as well for people who want to stay up to date on what we've got going on. And we'll post it on Facebook, and we try to spread it in as many ways as possible once we have something happening. So
Awesome.
yeah, thank you. Good question. Got people, couple people saying thanks in the chat. Thank you all for being here. Yeah, if there's no more questions, we'll let you go.
okay.
Everybody have a good night.
Thank you, John.
you.
That was excellent. Really appreciate it.
Okay, thanks. Bye.